Uh, Good morning, students. As I've taken a part of this in Google Meet, but due to the network connectivity, it was really difficult for some of you to understand. Okay, so in according to our syllabus, we'll be dealing with first one is mean, median, and mode. Okay, that is a very simpler one that I think you have done in your school days. So just to recall that. Mean, I'll be writing here. Okay, so the mean is the average value of any of a data set. Okay, say for example you have a data set like this: 5, 2, 2, 3, 4 and 6. Okay, and one more you can add, just 7. Okay, so mean means what you do is you add the individual data set. So 5 plus 2 plus 2 plus 3 plus 4 plus 6 plus 7 divided by 1, 2, 3, 4, 5, 6, 7. So this becomes summation of x divided by number of data. Okay, so summation of x means individual data divided by number of data. That gives you a mean. Okay, so next one is median. Median भनेको चाहिँ के हुन्छ? It signifies the mid value. Okay, so whenever you are doing it, writing it a mean, median, के पनि भन्यो भने, so first what you need to do is you arrange the data set. You arrange the data set according to ascending order. This thing here lowest for start gara. So there are 2 2s followed by 3, 4, 5, 6. Ascend गरेर चाहिँ ascending order मा राखेर चाहिँ, so the mid value कहाँनेर आउँछ, that will be your median. Okay, so that is median. Another one is mode भनेको चाहिँ के हुन्छ भन्दाखेरि, mode is the maximum number of value that is repeated for the more number of times. यहाँनेर के छ, 2 चाहिँ it's repeated for 2 times. Okay, so that mode signifies the data set which is repeated for the most number of times. That gives you the mode. Okay, so these are the simpler forms that I won't go into detail of this. Okay, so today we'll be dealing with a standard deviation. Okay, so in standard deviation what we have, I think I have already discussed with you in your this thing Google Meet also. So the definition of standard deviation, it's a qualitative expression by how much the member of a group or the value differ from mean value भनेको छ. Okay, standard deviation भनेको it's a measure of variance. But it's a measure of variance भनेको चाहिँ हाम्रो, say for example individual data हरू चाहिँ हाम्रो mean data बाट कति deviate भएको छ भनेर, that explains the standard deviation. Okay, so now, okay, as I've already told you, it's a measure of variation. के variation measure गर्छ भन्दाखेरि, how much our individual data set it varies from the actual mean of a data. But this is a mean बाट चाहिँ कति data के गर्छ हाम्रो individual data variate भएको छ, that is calculated by standard deviation. बुझ्दैछ? अब के गर्छ standard deviation, individual mean बाट कति कति deviate भएको छ त्यो सबै calculate गरेर चाहिँ एउटा figure दिन्छ, that is standard deviation. And this is the most accepted among all other variants or variants निकाल्ने के छ भन्दा, one is range, another one is quartile deviation, another one is mean deviation. यिनीहरु पनि के हो, अरु variants नाप्ने, like say for example standard deviation is one of them. त्यस्तै अर्को हुन्छ range, one is quartile deviation and mean deviation. That I have already shared the link with you all people. Range भनेको के गर्छ, it considers the two value. But this is कुनै पनि एउटा data set मा के गर्छ, when you arrange this in the ascending order, तिमीले lowest value, say for example lowest value is 0, it ranges to 50. भनेपछि range भनेको the lower value and the upper value. भनेपछि तिमीको data set चाहिँ यतिबाट यति उसमा के भन्छ variate भएको छ भन्दाखेरि, that signifies the range. तर range लाई किन पनि अहिले most यो अहिले variation मा किन accept हुँदैन भन्दाखेरि, because it takes only two values to denote the range. That's why it's discarded. Other comes quartile deviation भन्ने छ अर्को, another terminologies to explain variation. But this quartile deviation ले के गर्छ, it takes only 50% of the data set. तिम्रो data set, if a data set is given to you, it takes only 50% of the account of the data set. That it is also discarded. अर्को mean deviation छ, this is more or less accepted than the range and the quartile deviation, but Again, in mean deviation, what happens is the mean deviation if there are any negative values भनेको कुनै पनि values को अगाडि negative signs हरु छ भने चाहिँ त्यो values हरुलाई चाहिँ यसले लिँदैन. Okay, for that reason the other measure of variation like range, quartile deviation and mean deviation in the like त्यति statistical tools हरुमा in the measure of variations मा चाहिँ count गर्दैन. So we count standard deviation as a perfect measure of the variance of how much the individual data set are variated from the actual mean. Okay, so till here you have understood this. Now we'll be going into the formula how to calculate that mean. Okay, so standard deviation, it's denoted by sigma, but this it's a square root of what you call square root of this is x, the individual reading. I'll just tell you the formula. When I do the sums, you'll be able to understand this. So it's summation of x minus x bar whole square divided by n. N भनेको number of data set, x is the individual value, and x bar is the mean, assumed mean of the particular data set. But this sometimes this x minus x bar it's also denoted by d. Okay, so this x minus x bar it's denoted by d. So in some case it's written as summation of x minus x bar नलेखेर summation of d लेख्दा पनि हुन्छ. Okay, so this d is denoted by x minus x bar is denoted by d. So this is a main formula of standard deviation. Okay, so another shortcut method to calculate standard deviation, shortcut method, same formula, but it's written in slightly different way. That is summation of d square भनेको x minus x bar square divided by number of data minus summation of d whole square divided by n भनेको चाहिँ के हो? Again, यो दुईटा difference है. One is summation of d square. तिमीहरुको पहिला के गर्छ? You calculate d, next one you calculate d square calculate गरेको छ. So here it is a summation of d square. यसको summation लाई this is the one. यहाँ चाहिँ summation of d भनेको छ यो d लाई add गरेर जति आउँछ that is summation यो. Don't get confused in these two values. More or less it looks similar, but one is the summation of square root of d, which is x minus x bar ko summation or d square ko summation, and another one is summation of d only. The summation of d भनेको चाहिँ यो d. यो d र यो d कसरी calculate गर्छ? When I'll be dealing with the sums, you'll be able to understand that. Okay. Next one is if the data set is given in an interval form. Interval form भनेको नि अहिले interval form भएको I'll give you one of the example. त्यहाँनेर के छ? त्यहाँ चाहिँ the formula is bit different. That is sigma is equal to I भनेको I is the interval in which your data set is differentiated. Say for example तिमीहरुको 10 to 15, 15 to 20, 20 to 25 fixed interval set मा दिएको हुन्छ. Either it can be 10 to 20, 20 to 30. Okay, so out here the interval is 5, यहाँ पनि 5, यहाँ पनि 5. So in the first case, this I will be 5. Okay, in second case, the interval is 10. So in second case, the interval is 10. Rest, the formula is similar, but here frequency is given. Summation of FD दिएको छ. Why FD is given? त्यो पनि when I'll be doing the sum, you'll be able to understand the formula. Okay, so simpler. The formula for standard deviation is summation of x minus x bar. X भनेको the data set, x bar भनेको the assumed mean, त्यसलाई whole square divided by n. This is the actual formula. तर अलिकति shortcut method मा के भनेको छ? Shortcut method मा यही formula लाई अलिकति easy, simpler way to do the simplification of the thing. Summation of d square divided by n minus summation of d divided by n whole square. Again, yes, your value, there is a difference in this two value. I have already explained you. अर्को चाहिँ if the data set is given in an interval form त्यसमा I हुन्छ या FD पनि निकाल्नु एउटा there is different methods for that. I'll explain that. Okay, so this is for standard deviation. Now since the board is small, again I'll rub this, I'll write the sum again, I'll explain you. Okay, okay, now let's come to the sum. Okay, so I've already given the sum. There are 1, 2, 3, 4 data set of any data set. It might be height of the students or any data set. Okay, so first this one is given to you. Okay, the X or the data set. So the data set, there are 4 data set. So this is 16, 13, 17 and 22. Okay, so now according to the formula, what we require is we have X. X is given to you. Okay, so X is 16. Out here it's 13, 17. So next step we require X bar. So what is X bar? X bar is the mean of the value. Okay, so the process of calculating mean is, so summation of all this data set, that is 16 plus 13, 17 plus 22, it becomes 68 divided by number of data 1, 2, 3 and 4. So 68 by 4 is equal to 17. So here the data of X bar is equal to 17. That is the assumed mean of the data set. Okay, so when we have X bar means, now next step what we have to do is we'll be calculating X minus X bar. Okay, so individually it becomes 16 is X is 16, 17 is the mean, so this becomes minus 1. Second one, X minus X bar is equal to 13 minus 17, it's 4. Out here 17 minus 17, it's 0. 22 minus 17, it's 5. Okay, so now we have D. So D is minus 1 plus 4 AI. In next step, what we require is D square. Since in the thing, so like this is simpler way. So this becomes X minus X bar whole square. That is X minus X bar is denoted by D. So D square, it's nothing but D. We square the value. Square. So 1 minus 1 is equal to 1. Minus 4 into minus 4 is equal to 16. Minus into minus becomes plus. Plus, since plus we don't write it in a thing, mathematical figure. It's considered plus in the front. Okay, so 0, 0, 0. So summation of D square becomes 42. Okay, since I have given 2 or 3 formulas, the simpler one is this one. Shortcut one, this one. Okay, so we'll be taking both the formula and doing the equation. Out here it's summation of X minus X whole square is equal to summation of D square. Summation of D square. Square. So summation of D square is equal to 42. Summation of D square. D square add it becomes 42. So N is equal to 4. Now the answer of standard deviation is 3.2. Okay. Now shortcut method ma same formula alikati twist gareko. It's summation of D square minus summation of D whole square, right? Aba yahanera summation of D square bhaneko chai, this is summation of D square is equal to, this one is 42 minus summation of D बाहिरबाट square छ. So this is summation of D. यहाँ छ E. यसलाई add गरिम के गर्छ? So this becomes 0 because minus गरिम नि, this becomes minus 5 plus 5 गरिम नि के गर्छ? It becomes 0. So this value is 0. You got the difference? Summation of D square भनेको this is the one. Summation of D तर बाहिरपट्टि square भनेको this is the one. So when you calculate this also, you get the same value. It's 3.2 or it's 3.2. So whichever formula you apply and do it, it's very simple. You get the same value. Understood? So this is the calculation of standard deviation through a normal data set. Now I'll be dealing with another kind of data set in which the data are given in an interval form. Interval form bhako data set haruma. Now we'll be dealing with that. But now your value ले के सिग्निफाई गर्छ भन्दाखेरि हाम्रो इन्डिभिजुअल डेटा सेटबाट चाहिँ कति मिनबाट डिभिएट भएको छ भन्दाखेरि It's the round figure is more or less 3.2. So this is the measure of variation of the data set. Okay, so next we'll be doing another example of a data set in which it's given in a interval form. Okay. Okay, so now we'll be calculating the standard deviation in which the data set is given in the form of an interval data set. Okay, so whenever this kind of the form of the data set is given, it's always associated with the frequency. भनेको चाहिँ your say for example this interval data set, it signifies in a large number of a data set. When the data set is too long, it will be given in a form of a interval data set. भनेको चाहिँ के भनेको भन्दाखेरि say for example 10 to 20 years, or it may be the IQ level of a student. But this is when the student number is very large, so you try to arrange the data set. Arrange गर्दाखेरि it usually you write in a interval form. Okay, so 10 to 20 IQ bhako, there are 5 students. 20 to 30 IQ bhako, there are 12 students. So this 5, 12, 15, 20, 10, this represents the frequency. Okay, so this is the range data. So when you arrange this data in order to calculate the frequency, in order to calculate the standard deviation, now as I mentioned you earlier, the formula is slightly different in case of the frequency distribution in case of the interval data. So this is denoted by I. Okay, I is the interval. Say for example out here the interval is 10 to 20 minutes, interval is 10, 10, 10 like this. Sometimes it might be given like 10 to 15, 15 to 20. So the interval will be 5. So this I denotes the interval of the data set. Okay. So F into D is equal to, when we were calculating this, we were straight away writing summation of D square divided by N, summation of D whole square divided by N. But here in case of interval data set, this frequency is also added in the formula. Okay, so now this kind of a data set is given. Now what you do, you arrange the data set this way. So as I've already mentioned, the number of students is denoted by frequency. Okay, so the range data LINA I've just written in this form. So next, now our हामीलाई data ma what do we require? We have to take x minus x bar, right, in order to calculate standard deviation. So we need x. हामीलाई x त दिएको छैन यहाँनिर, it's in the interval form. So in order to calculate x, what we do is we take out the mid value of the data set. Mid value कसरी गर्छ भन्दाखेरि, so the lower data case plus upper data case. Out here it will be 10 plus 20 divided by 2 is equal to 10 plus 20 is equal to 30 divided by 2 is equal to 15. So in second case, you add this and divide it by 2. So 20 plus 30 is equal to 50 divided by 2, 25 is a D. Okay, so when you get the mid value, this is denoted by x. Okay, so this is x. Now x. Now what do we require? We require x bar. X bar भनेको it's a mean. Mean भनेको what do we do? We take this summation of x. कति आउँछ यहाँनिर? It comes somewhere over 285. Summation of x divided by number of data भनेको number is frequency now. It's not 1, 2, 3, 4, 5 here. It's the frequency ko summation of frequency. N is F. Okay. So this comes somewhere over 18 आउँछ यहाँनिर. Okay. So this x bar, the mean of the individual that comes somewhere over 18. Now next step मा के छ, हाम्रो के छ, अलिकति slightly अगाडिको केसमा d चाहिँ straight away के हुन्थ्यो, d is equal to x minus x bar. छ कि छैन? Simple. यही अब next step अब standard deviation calculate गर्दा we require x minus x bar, that is denoted by d. Okay. तर interval data set मा चाहिँ what happens is this d is equal to this divided by I. I is the interval. Okay. So in first case, what will be the case is x भनेको, what is x? X is the mid value, that is 15, minus x bar is equal to 18 divided by interval कति छ 10. So this becomes somewhere over minus 3 divided by 10 आयो भने कति हुन्छ? So somewhere over 0.3 कति आउँछ होला? Okay, so this is equal to 0.3. This somewhere comes around kati huncha 25 minus 18 divided by 10 is equal to 5. 7 divided by 10, it comes somewhere over 0.7, something like that. Okay, so this way it comes like this. So this is D. Okay, now as I've already mentioned you, in case of the interval data set, this frequency is added. Alikati slightly there is a change in the what you call in the formula. So this becomes summation of, so next what जुनै केसमा पनि we require f र d चाहिन्छ नि, यहाँ पनि f र d चाहिन्छ. So next we write is f into d is equal to f भनेको 5 into d भनेको this d, f into d is equal to 5 into d is 0.3, 5 3 is a 15, so 1.5 f into d. Okay, so you do the square root of f into d. So 1.5 into 1.5 jati आउँछ, this becomes f into d. Same way you write the summation of fd, summation of f and d, you write same way summation of fd square. Okay, now you put in the formula this way. Okay, this sum has already been given in, I'll be sharing the PPT slideshow. But this out here there is a slightly mistake. Yahanera chai yo x minus x bar ko the sum, there is a slightly mistake out there in the sum. Okay, so this will be the actual process of doing it. Okay, so तिमीले यो खासमा त अब standard deviation interval form मा त्यति दिएको पनि हुँदैन, तर whenever the data is given in the interval form, you need to understand that as main thing. What you have to do is you have to take out the mid value, that is x, because we require x minus x bar. X ko bhaneपछि that is the mid value. Okay, x bar bhaneko that's assume mean. Assume mean bhaneko this x divided by number of data set. Your frequency ma feri yo 1 2 3 4 5 6 7 hunदैन है. It should be the total frequency should be added, that is 68. So that means you take out the mean, that is a summation of this mid value divided by n is 68. बुझ्दैछ? अन्त अर्को कुरा याद गर्नुपर्ने, this fd हुन्छ यहाँनेर र fd square हुन्छ. Why? This frequency has to be taken into account. Okay, so that this is a slightly change in the what you call the formula to calculate the standard deviation. So अलिकति अर्कोमा के चेन्ज हुन्छ, I is also given. I is the interval, कति इन्टरभलमा यो डेटा डिस्ट्रिब्युट भएको छ भनेर. Okay, so more or less you have understood this. Okay, so this is standard deviation. Okay, same another one is standard error. Okay, standard, in order to calculate standard error, the formula is simple. So standard error of a mean is equal to sigma divided by number of data. Okay, in order to calculate standard error. Now, what is the difference between standard error and standard mean is standard deviation and standard error is, okay, standard okay. So standard error भनेको चाहिँ के हुन्छ भन्दाखेरि, as I've already mentioned you, whenever we are doing any kind of census, say for example also human ko census होस्, in order to count humans, in order to count animals हरु के छ आजकल चाहिँ to go and count head count गरेर count गर्नु, it's too time consuming. This it's time पनि consume हुन्छ, more amount of economy is required, more so in order to minimize this, आजकल के गर्छ statisticianहरूले के गर्छ, they tend to do more things in a very short duration of a time. त्यसै कारण हामीले के गर्छ, there is a terminology known as absolute abundance and another one is relative. abundance भन्छ. Absolute भनेको you count all the individual. Humans को होस्, if you are going on a wildlife survey, wildlife census को होस्, डल्लै काउन्ट गर्नु आजकल पोसिबल छैन. ओके, ह्युमन्स को केसमा त अब ह्युमन्स को केसमा पोसिबल छ, बट इट्स टू टाइम कन्ज्युमिङ. Okay, whereas in case of animals को केसमा, whenever you are going on an abundance estimation of animals, going into the forest, counting all the animals is totally impossible. त्यसै कारण आजकलको के गर्छ, डेन्सिटीहरू फाइन्ड आउट गर्ने डेटामा चाहिँ, say for example you have 10 tigers in an area, that is always followed by plus minus standard error भनेको हुन्छ. That means तिमीले के भन्नु खोजेको भन्दाखेरि स्ट्यान्डर्ड एरर चाहिँ कहाँ लाग्छ भन्दाखेरि चाहिँ हामीले डेन्सिटी निकाले अरे कुनै पनि केही चीजको, द्याट इज अलवेज एसोसिएटेड विथ स्ट्यान्डर्ड एरर भनेको. किन भन्दाखेरि हामीले गएर जंगलमा गएर यु काउन्टेड द एनिमल्स, तर यो एनिमल्स यति नै छ भन्नु सकेको होइन, तर हामीले स्ट्यान्डर्ड एरर जोड्नुको कारण चाहिँ के हो भन्नुको खोजेको कारण. से फर एक्जाम्पल यु हेभ डेन्सिटी अफ टाइगर इज 10 इन द फरेस्ट, प्लस माइनस तिम्रो स्ट्यान्डर्ड एरर के आयो, हामीले फर्मुला निकालेर, दिस इज सिग्मा इज नथिङ बट दिस इज स्ट्यान्डर्ड डिभिएसन. अघिको केसमा स्ट्यान्डर्ड एररको फर्मुला हो स्ट्यान्डर्ड सिग्मा भनेको स्ट्यान्डर्ड डिभिएसन फलोड बाई एन हुँदैछ. अघिको प्रोसेसमा स्ट्यान्डर्ड डिभिएसन निकाल्यो, त्यहाँदेखि निकालेर एन भनेको अलरेडी इट्स गिभन इन द थिङ, यसलाई स्क्वायर रुट गऱ्यो भने स्ट्यान्डर्ड एरर आउँछ. यो फर्मुला हालेर सपोज तिम्रो स्ट्यान्डर्ड एरर यहाँ 5 आयो अरे, सपोज है. नाउ अब डेन्सिटी कति भयो, यु आर टेलिङ 10 plus 5 is equal to 15, 10 minus 5 is equal to 5. So you say in the forest the density of tiger it ranges from 5 to 15 भन्दैछ. ओके, भनेपछि मैले गएर चाहिँ जंगलमा गएँ, यु अप्लाइड अल द स्ट्याटिस्टिक्स होइन, तिम्रो स्याम्पलिङ डिजाइनहरू सबै लगाएर when you calculate the density of the tiger, you say that the tiger population ranges from 5 to 15 भन्दैछ. Okay, this is standard error. Standard error is associated here. अर्को केस दिन्छु तिमीलाई. अन्त स्ट्यान्डर्ड एररको भ्याल्यु चाहिँ जति लेस हुन्छ त्यति नै your estimation is more robust, your estimation is more accurate. But this is, say for example you have a density of 50 plus minus तिम्रो स्ट्यान्डर्ड एरर आयो सपोज 30 आयो सपोज, हेर है, भनेपछि your data is ranging from 50 plus 30 is equal to 80 बुझ्दैछ. 50 minus 30 is equal to 20. यहाँ एउटा केस यो भयो. अर्को केसमा सपोज 50 plus minus 5 आयो अरे, so this data set it ranges from 50 minus 5 is equal to 45, 50 plus 5 is equal to 55. So which one is more robust, you say? This is standard error. Okay, so तिम्रो जंगलमा गएर your density of the tiger it ranges from 20 देखि यो जंगलमा चाहिँ 20 देखि 80 सम्म भन्नु, it sounds more robust, or you'll be saying that the population of tiger it ranges from 45 to 55. Which one is more robust? This looks more robust because the interval is very less. Okay, भनेपछि जति पनि स्ट्यान्डर्ड एररको भ्याल्यु लेस हुन्छ, it signifies your sampling design is more robust भनेर. Okay, more the standard error, जति स्ट्यान्डर्ड एररको भ्याल्यु बेसी आउँछ त्यति नै it signifies that there is some flaws in your sampling techniques. यो चाहिँ के गर्छ, it signifies either you have to take more number of samples, or या तिम्रो your designing was wrong, so it signifies that. So this is standard error of a mean. So standard deviation and standard error, that's slightly different. तर whatever you do this, आजकलको के गर्छ फिल्डमा, you never have to do it manually. कहिले पनि manually गर्दैन. Why? Because it's too time consuming. आजकल त everything is done in what you call तिमीहरूको सफ्टवेयर्सहरू छ. Say for example SPSS is there is distance. So whenever these are all the softwares that are used in wildlife techniques, population estimation techniques, जुनै पनि गर तिम्रो standard deviation, standard error automatically दिन्छ. It's just that you need to interpret it properly. Interpretation गर्नु चाहिँ सिक्नुपर्छ, बस त्यति नै हो. Okay, so this is a difference between the standard error and a standard mean. Okay, I hope you have understood this. Okay, if you don't understand, please go through the videos, go through notes, you'll be able to understand. Okay, thank you.